not like anything crazy. So just whatever questions you have, just ask me, okay? Okay, so we're gonna start with 2D minus 4. That's our problem. And we're gonna put it to the fourth. Here's what I like to do. I like to first look at the row that I'm gonna need. So the fourth is always gonna be this row. So this is my row. All of these numbers are gonna be my coefficient for every single term in the entire problem. So that's what these are important for, okay? So I'm gonna go in and I'm gonna put in 1 plus 4 plus 6 plus another 4 plus another 1. So far, these are my coefficients. That's all I have for now. Then I'm going to take a look and I'm going to say, okay, I have 2D. That's my first term, okay? So I'm going to put 2D in every single term. And the reason why I'm doing that is because I know when I factor, like, you know, when you make the box like we did over here, I know that everything is going to get multiplied by everything. So each of these has some level of 2x, and each of these has some level of -5, right? So I know that each of these terms is going to have some level of 2D. And the way that I know which level it is I'm going to start with my highest exponent, which is going to be 4.
Yeah.
And then I'm going to go down 4, 3, 2, 1, 0. Okay. And then I'm going to do the same thing with 4, but I'm going to make it negative because this is minus. So I'm going to put -4 in each of these terms. And in here, I'm actually going to also start with 4, but I'm going to start with 4 at the very end. And I'm going to explain in a second why I need to start at the very end. Okay, do you see how when you add up your exponents, every single term has an added exponent of 4?
Yeah.
Right? So that's the goal. Because this is 4, I want all of my exponents in every single term to add up to 4. Now, again, I don't know what Pascal was thinking. I don't know if he was on something that was not healthy. I don't know how he came up with it. Like, I have no clue. Maybe one day I will look into it and I will be like, oh, Nani, like, this is it. But for right now, I don't know how he came up with it. Okay. Maybe he had some trippy dreams. Who knows? But these are the rules. Like, the rules are you're going to see every single term in every problem, and they're all going to have different exponents, and all of the exponents are going to add up to 4. So we're not yet done. Like, you think we're done, but we're not. We're going to go in and evaluate every single one of these terms. We're going to go in and be like, okay, this is nothing because it's to the 0 power. So that means I have 1 times 2 to the 4th times d to the 4th. That should probably look like this. So that's going to be what, 16 d to the 4th? And that's my first term. So then I'm going to go in here. I'm going to have 4 times 2 to the 3rd times d to the 3rd times -4. So that's going to be a lot. That's what, 8? 8 times 4. 4 times 4 is 16 times 8. Who knows what that is? 80, no. 16 times 8 is 128. But negative, because this is negative. So -128 d to the 3rd. And we're going to continue. So far, talk to me about questions.
I think I've got this so far.
It's making sense, right?
Yeah, I understand what you're explaining.
Okay. So, and again, this is fully fair game for your final.
Mm-hmm.
So then it's just a matter of like doing the math.
Mm-hmm.
What the heck is 4 times, oh, 64. Hold on. So 64 times 8. But then this is negative because of this. And then this guy goes away. So then it's going to be 4 to the 4th. So then this is just going to be negative 4 to the 4th, like that, which is 256. And then we know that we were going to add all of them, but because this is negative and this is negative, we can like combine it all to this. And again, because you have a calculator, you can like punch in the numbers, just like multiply them. So you don't have to like waste brain energy, you know?
Mm-hmm.
And then ta-da, this is it.
Mm-hmm.
Final answer. So let me